Hi guys, Mr. Palmer here with an AP Chem question again. This one is about calculating concentration of solutions. So this takes us into a little practice looking at 4 different measures of concentration: mass percent, molarity, molality, and mole fraction. So just want to go through some example problems and talk about these. What's really important is that you remember what the definitions are. So these are the 4 definitions, and these are going to be necessary in different situations. So sometimes you might need a mass percent, sometimes you might need a molarity, sometimes you need the mole fraction. And you're going to want to be able to calculate these and maybe given one, convert to another unit. So let's look at an example question involving this. So in this question we have a solution that's prepared by adding 5.84 grams of formaldehyde. You're given the formula to 100 grams of water. The final volume of the solution is 104 milliliters. That's important to know when we're doing molarity. And we want to calculate the molarity, molality, mass percent, and the mole fraction of the formaldehyde solution. So let's go through each one. As I said, what's important is to remember the definition. So let's start by looking at the mass percent. And that's the mass of solute over the mass of total solution. So back in the problem, it told us that there were 5.84 grams of formaldehyde. So we're going to put that on top. 5.84 grams H2CO. And we want that over total solution. So if we look up here, we're adding it to 100 grams of water, which means the total solution is going to be the 5.84 grams of water, of the H2CO, the formaldehyde, and we're going to add that to the 100 grams of water. Multiply by 100 to make it a percent, and that's going to give you 5.52%. You'll see that I'm writing that with 3 significant figures, and that's what I was given, the smallest number in the problem, the 5.84. Okay, let's look at molarity. Again, here's our definition of molarity. So we're going to need moles of solute. So let's take our 5.84 grams of H2CO. We need to find its molar mass. So 2 hydrogen, 1 carbon, and 1 oxygen is going to give you 30.03 grams for every 1 mole of H2CO. And that gives you 0.194 grams of the H2CO, our solute. We're going to have to put that over the volume, again, liters of solution, so we have 0.194 moles, sorry, that's not grams, that was moles of H2CO. And, well, what did we know? It told us that the final solution had a volume of 104 milliliters, right? But we don't want moles per milliliter, we want moles per liter. So we're going to have to convert that into liters, and there's 1,000 milliliters in every 1 liter. Okay, so we're going to wind up with moles over liters. You do the math, it's 1.87 molar. And we give it a capital M. The symbol of molarity is capital M. Let's look at the molality next. Molality is really only used when we're doing freezing point depression and boiling point elevation problems, but it is necessary for you to calculate that. Again, remember, this one is not per liter of solution, this is per kilogram of solvent. So we already had our moles from the last problem, which was 0.194 moles of the formaldehyde, the H2CO. And now we need to put that over kilograms of solvent. Well, we had 100 grams of the solvent, which was water. We just need to turn that into kilograms. There's 1,000 grams in every 1 kilogram. So our grams of water are going to cancel, and it's obvious you're just dividing by 0.1, so it should be 1.94. And again, it's little m for molal, not molar, molal. Okay, and our last one is the mole fraction. And mole fraction is the moles of whatever it is you're looking for. It could be the solute or the solvent over the moles total. So we need the moles of the formaldehyde and the moles of water. We already know that the formaldehyde was 0.194 moles of the H2CO. For the water, we had 100 grams of it. We're going to divide by 18.02 its molar mass to get the moles, and it gives you 5.549 moles of water. And you might ask, why did I take it that far? Well, I had 4 sig figs here, I have 4 sig figs over here. So we need to find the total moles. We're going to put our 0.194 moles of the H2CO. The total moles are going to be 5.549 moles of water plus the 0.194 moles of the formaldehyde. And this is not times 100, this is a fraction. So it's going to be part of 100. So the mole fraction, which is this symbol, looks like X. It's a chi of H2CO, is going to be 0.0338, which means that the mole fraction of the water, the solvent, is going to be the difference here. So sometimes we want to look at the mole fraction of the actual solvent if we're doing something like Raoult's law for vapor pressure. If we subtract, that's 0.9662. This is a unitless number, and again, it should add up to be exactly 1 because it is a mole fraction. And that's it. We'll explore some other example problems a little later.